How to create custom structural directive in Angular? Here is an example of a custom structural directive in Angular. Step 1. Create a new file and name it myFor.directive.ts. Step 2. Import the required dependencies. Step 3. Add the @directive decorator to your class and specify the selector for your directive. In this example, we are creating a structural directive with the selector *myFor. Step 4. Define the constructor and inject the template ref and view container ref services. Step 5. Add an input property to receive the data to iterate over. This input property is where you will pass in the data to iterate over. The set function uses the view container ref to create a new embedded view for each item in the collection and passes the item and index as context to the template. Step 6. Export the class. Once you have created your directive, you can use it in your templates like this. This will apply the directive to the ngContainer element and iterate over the items array, creating a new div for each item in the array. The letItem syntax declares a local variable item in the context of the template, which you can use to access the current item in the iteration. Can you explain ngOnInit lifecycle hook in Angular? ngOnInit is an Angular lifecycle hook that gets called once when a component is first initialized. This hook is useful when you need to perform initialization logic for your component, such as fetching data or initializing variables. For example, you might use ngOnInit to fetch some data from a server and use it to populate your component's view. Here is an example. In this example, we are using ngOnInit to fetch data from a myDataService and store it in a local variable called myData. We are using the subscribe method to handle the async response from the server and update the variable with the received data. Note that ngOnInit gets called once when the component is first initialized, so this logic will only be executed once per component instance. Overall, ngOnInit is a useful hook for performing initialization logic for your components. By using ngOnInit, you can ensure that your component is fully initialized and ready to use before any other logic is executed. For more such videos, please like the video, subscribe the channel and click on notification icon. Thank you. Can you explain the concept of dependency injection in Angular and how it helps with modularity and testing? Dependency injection, D, is a design pattern that is used in Angular to allow components and services to be loosely coupled and more easily tested. In Angular, dependency injection is implemented using a hierarchical injector tree, with services provided at different levels of the tree. The concept of dependency injection is based on the idea that rather than having a component or service instantiate its own dependencies, those dependencies are provided to it by an external entity, which is typically an injector. This allows for a more modular and flexible design, as different dependencies can be easily swapped out or modified without affecting the overall structure of the application. In an Angular application, dependency injection is used to inject dependencies into components and services using constructor injection. This means that when a component or service is instantiated, its dependencies are automatically resolved and provided by the injector. This allows developers to write code that is more modular and reusable, as dependencies can be easily swapped out or modified without changing the code itself. In addition to promoting modularity, dependency injection also helps with testing, as dependencies can be easily mocked or replaced in test environments. By injecting mock or test versions of dependencies, developers can test components and services in isolation without needing to worry about the behavior of their dependencies. Overall, dependency injection is a powerful tool for promoting modularity and flexibility in Angular applications, while also making them easier to test and maintain. By using dependency injection to inject dependencies, developers can create more modular, flexible, and testable code, leading to a more robust and scalable application. Can you explain the folder structure and bootstrapping in Angular? In Angular, the folder structure and bootstrapping process are important parts of the project setup. Here is an overview of these concepts. Folder structure. When you generate a new Angular project using the Angular CLI, it creates a default folder structure for you. Angular has a well-defined folder structure that is designed to help developers organize their code in a way that is easy to manage and maintain. The most common folder structure used in Angular is the following. Here is an example of what that structure looks like. Let's briefly go over what each of these folders and files are. E2E, this folder contains end-to-end tests for the application. Node_modules, this folder contains all the dependencies for the application. When you run npm install, these dependencies are installed into this folder. src, this is the main folder for your application's source code. src app, this folder contains the main components and modules of your application. src app.component.ts, this is the main component of your application, which contains the logic and behavior for the root component of the app. src app.component.html, this is the template for the root component of the app, which defines the layout and content for the component. src app.component.css, this is the CSS styles for the root component of the app. src app.module.ts, this is the main module of your application, which declares the components and services that are used in the app. src assets, this folder contains any static assets, such as images or fonts, that are used in the app. src environments, this folder contains configuration files for different environments, such as development and production. src index.html, this is the main HTML file for your application. src main.ts, this is the main entry point for your application, which bootstraps the app module. src styles.css, this is the main CSS file for your application. Angular.json, this is the configuration file for the Angular CLI. Package.json, this is the configuration file for npm, which contains information about the dependencies and scripts for the app. tsconfig.json, this is the TypeScript configuration file for the entire project. tsconfig.app.json, this is the TypeScript configuration file for the app. tsconfig.spec.json, this is the TypeScript configuration file for the tests. Bootstrapping. Bootstrapping in Angular refers to the process of starting up the application and loading the main module, app module, of the app. This process is initiated in the main.ts file, which looks like this. Here, we import the platform browser dynamic function from the @Angular platform browser dynamic package, which is responsible for compiling and bootstrapping the app in the browser. We also import the app module from the app.module.ts file, which is the main module of the app. Then, we call the bootstrap module function and pass in the app module as an argument. In this example, the platform browser dynamic method is used to create a platform for the application to run on. The bootstrap module method is then called to bootstrap the app module. The app module is the root module of the application and it is responsible for importing all of the other modules and components that make up the application. Once the application is bootstrapped, Angular takes over and starts handling user interactions and rendering the application on the screen.
How do you handle version updates and migration in Angular projects? So basically this question asks to experienced Angular developers who have more than 3+ years of experience. So let's see the solution. Okay. Hello everyone, welcome back to Frontend Insights. Today we have an important topic to discuss for all you Angular developers out there. Handling version updates and migration in Angular projects, whether you are working on a small project or a large scale application. Keeping your Angular version up to date and managing migration is crucial for performance, security, and compatibility. So I'm giving you the solution step by step. Okay, so the first section, like why version updates are important. So before we dive into the how to part, let's quickly talk about why version updates are important. So version updates is important for it improves your performance, your application's performance. On the updated version, you get the new features, you get the security updates, and some bug fixes are there. Okay, so as you can see, staying updated ensure your application runs smoothly, securely, and take advantages of latest feature. So on the second step, so checking the current version. Okay, so first thing first, let's check the current version of Angular in your project. So for this, we use the command ngversion. Okay, so this command will display the Angular version you are currently using. Make a note of it before proceeding. On the third step, like updating the Angular CLI. So now let's update the Angular CLI to the latest version. So for this, we have the command npm install -g @angular /cli @latest. So this command install the latest versions of Angular CLI globally on your machine. Okay, so the fourth section is like step is like updating Angular core and dependencies. Okay, so next update Angular core and other dependency in your project. So for this, so we use the command ng update @angular /core @angular /cli. So this command updates Angular core and CLI to the latest versions compatible with each other. Okay, so in the section 5, handling the major version migration. Oh, sorry. Okay, so if you are moving between major versions like from Angular 10 to Angular 11 or Angular 11 to 12, you may need to perform migration. Okay, so for this we have the command ng update @angular then /core @new version, means whatever the version you want, latest version you want to update, you can put there. Then @angular /cli, then new version, then hyphen migrate hyphen only. Okay, so this command will help you migrate your project to the new version. Don't forget to check the migration guide for any additional steps specific to the version you are updating to. Okay, so on the last step, like resolving the updates error. So during the update process, you might encounter some errors. Don't panic. Most of these errors can be resolved. Okay, so I'm giving you some tips for this. Okay, so check the error message carefully. And second, refer the Angular update guide for troubleshooting. And third, sometimes you may need to update other dependencies or refactor your code. Okay, so once you have resolved the errors, try running your application again to ensure everything is working as expected. Okay, so here I'm giving you the conclusion. So there you have it, a step-by-step guide to handling version updates and migration in Angular projects. Remember, staying updated not only keeps your application secure and performant, but also allows you to leverage the latest feature and improvement offered by Angular. Okay.
What is Progressive Web Applications, PWA, in Angular? How to implement PWA in Angular? Angular provides built-in support for building progressive web applications, PWA. A PWA is a web application that provides a native-like experience to users by taking advantage of modern web capabilities like service workers, web app manifests, and push notifications. Here is how you can create a PWA in Angular. First, install the @Angular Service Worker package. This command installs the necessary packages and sets up the project for building a PWA. Second, configure the Angular Service Worker. The @Angular PWA package provides a configuration file, ngSWconfig.jso, that you can use to customize the behavior of the Angular Service Worker. You can add the following options to the file to enable caching of static assets, dynamic data, and HTTP requests. The Asset Groups section specifies the static assets that should be cached when the PWA is installed, and the Data Groups section specifies dynamic data that should be cached. Third, add a web app manifest. The web app manifest is a JSON file that describes your PWA, including its name, icons, and startup URL. You can add a manifest.jso file to the root of your project and configure it as follows. Fourth, test the PWA. To test your PWA, build the production version of your Angular app using the ngbuild prod command and serve it using a static file server like HTTP server. You should see a prompt to install the PWA. How would you approach building a large-scale Angular application with multiple modules and components? Building a large-scale Angular application with multiple modules and components requires careful planning and organization. Here are some steps that can be taken to approach such a project. Define the application architecture. Start by defining the architecture of the application. This includes deciding on the high-level design of the application, such as the overall layout and structure of the application, as well as the technologies and frameworks that will be used. Identify the modules. Next, identify the modules that will be needed for the application. This includes breaking down the application into smaller, manageable chunks, such as user authentication, data management, and user interface components. Each module should have a specific purpose and be responsible for a specific set of tasks. Define the components. Within each module, define the components that will be used. Components should be defined based on their specific tasks and responsibilities. For example, a component for displaying user data might be defined, as well as a component for managing user data. Plan the data flow. Once the modules and components have been defined, plan the data flow between them. This includes deciding on the input and output data for each component, as well as the communication between components. It is important to ensure that data flows efficiently and accurately between components. Define the services. Define the services that will be used within the application. Services are responsible for handling specific tasks within the application, such as fetching data from a backend API or handling user authentication. Each service should be defined based on its specific task and responsibility. Develop and test the application. With the architecture, modules, components, data flow, and services defined, start developing and testing the application. Begin by creating the core components and services, and then move on to creating the individual modules and components. Test each component and module as they are developed to ensure that they function correctly. Refine and optimize the application. Once the application has been developed and tested, refine and optimize the application. This includes optimizing the performance of the application, as well as improving the user experience. Deploy the application. Finally, deploy the application to a production environment. This includes ensuring that the application is secure, reliable, and scalable, and that it meets the needs of the users. Overall, building a large-scale Angular application requires careful planning and organization. By defining the application architecture, identifying the modules and components, planning the data flow, defining the services, developing and testing the application, refining and optimizing the application, and deploying the application, developers can create a robust and efficient application that meets the needs of the users. If you like the video, please like, share, and subscribe. How would you approach optimizing the performance of an Angular application? Optimizing the performance of an Angular application is an important consideration for any development team. Here are some approaches that could be taken. Reduce bundle size. One of the main factors that can slow down an Angular application is the size of the application bundle. Reducing the bundle size can be achieved through techniques like tree shaking, code splitting, and lazy loading. Optimize Angular templates. Angular templates can have a significant impact on the performance of an application. Optimizing templates can include techniques like using trackby for ngFor loops, using on-push change detection, and minimizing the number of bindings and event handlers. Use ahead of time AOT compilation. AOT compilation generates optimized code at build time rather than at runtime, which can significantly reduce startup time and improve the overall performance of an Angular application. Optimize the Angular change detection strategy. Angular's default change detection strategy can be resource-intensive, so optimizing the change detection strategy can help improve application performance. Strategies include using on-push change detection, immutability, and pure pipes. Use web workers. Using web workers can help improve the performance of an Angular application by offloading heavy computational tasks to a separate thread. Use caching and compression. Caching and compression can help improve the performance of an Angular application by reducing the amount of data that needs to be transferred over the network. Optimize API requests. Optimizing API requests can help improve the performance of an Angular application by reducing the number of requests, using caching, and using pagination. Overall, optimizing the performance of an Angular application requires a combination of careful planning, code optimization, and the use of appropriate tools and techniques. Why ngDoCheck lifecycle hook in Angular? ngDoCheck is another Angular lifecycle hook that gets called every time Angular checks for changes in the component. This can happen frequently, so it's important to be careful about what you do inside this hook to avoid performance issues. You might use ngDoCheck if you need to perform custom change detection on your component, such as detecting changes to non-Angular objects or arrays. Here is an example. In this example, we are using ngDoCheck to check for changes to the myArray input property. If the array has changed, we log a message to the console. Note that ngDoCheck gets called frequently, so we are careful to only perform our custom change detection logic if we really need to. It's worth noting that ngDoCheck should generally be used sparingly, as it can negatively impact performance if used incorrectly. In most cases, you should rely on Angular's built-in change detection system rather than implementing your own logic inside ngDoCheck. Can you explain difference between observable and promises in Angular? In Angular, both observables and promises are used for handling asynchronous operations. However, there are some important differences between them. Return value. A promise returns a single value or an error, whereas an observable can return multiple values over time. Cancellation. Promises do not have built-in support for cancellation, while observables do. This means that observables can be unsubscribed from to cancel an ongoing operation, whereas promises cannot be cancelled once they have been resolved or rejected. Operators. Observables can be used with a variety of operators to transform, filter, and combine the emitted values, while promises do not have built-in support for these operations. Eager versus lazy. Promises are eager, meaning that they immediately execute the asynchronous operation when created. On the other hand, observables are lazy, meaning that they do not execute any code until they have been subscribed to. In Angular, observables are the preferred choice for handling asynchronous operations because they provide more flexibility and functionality than promises. Angular's HTTP client service returns observables by default, which can be transformed using operators such as map, filter, and catcher. In summary, the main differences between observables and promises in Angular are: observables can emit multiple values over time, while promises can only return a single value or an error. Observables can be cancelled, while promises cannot. Observables can be transformed using operators, while promises do not have built-in support for this. Observables are lazy, while promises are eager. If you like the video, please like, share, and subscribe. What are the routing events in Angular? In Angular, routing refers to the mechanism of navigating between different views or pages of a web application. Angular provides a powerful routing framework that enables developers to map URLs to different components of an application and handle navigation in a structured and efficient way. There are several routing events that occur during the navigation process in Angular, including navigation start. This event is triggered when navigation starts. It provides information about the URL that is being navigated to and allows developers to perform any necessary actions before the navigation process completes. Routes recognized. This event is fired when the router recognizes the current route. It provides access to the current route and any associated parameters. Guards check start. This event is triggered when the router begins to check whether any guards prevent the navigation from occurring. Child activation start. This event is fired when the router begins activating a child route. Activation start. This event is triggered when a route is about to be activated. Guards check end. This event is fired when all guards have been checked and navigation is allowed to continue. Resolve start. This event is triggered when the router begins resolving any route data. Activation end. This event is fired when a route has been successfully activated. Resolve end. This event is triggered when all route data has been successfully resolved. Child activation end. This event is fired when a child route has been successfully activated. Navigation end. This event is triggered when navigation is complete and the new component is fully loaded. Developers can use these events to perform actions such as loading data, displaying loading indicators, or preventing unauthorized access to certain routes. What is the purpose of the ngOnChanges lifecycle hook in Angular? The ngOnChanges lifecycle hook in Angular is called whenever a data-bound input property of a component changes. It receives an object containing the previous and current values of the changed input property. Here is an example of how ngOnChanges works in a component. In this example, the child component has an @input property called input value. Whenever the value of input value changes, the ngOnChanges method is called with an object containing the previous and current values of the changed property. The ngOnChanges hook can be used to perform actions when an input property changes. For example, You could use ngOnChanges to update the component's state or perform some other action based on the changes to the input property. Overall, the ngOnChanges lifecycle hook is a useful tool for building reactive components in Angular. By leveraging ngOnChanges, developers can build components that respond dynamically to changes in input data and provide a more responsive user interface. Please like, share, comment, and subscribe. Can you describe the role of the Angular router in an Angular application and how it can be used to create dynamic views? The Angular router is a powerful tool for managing navigation and creating dynamic views within an Angular application. It allows you to define routes that map to different components in your application and then navigate between those components based on user actions or other events. Here are some of the key roles of the Angular router in an Angular application. Defining routes. The router allows you to define routes in your application by mapping URLs to specific components. This makes it easy to create a hierarchical structure for your application and to organize your code into separate components that handle different parts of your application's functionality. Managing navigation. Once you have defined your routes, the router provides a number of methods for navigating between them. You can use the router link directive in your HTML templates to create links that navigate to different parts of your application, or you can use the router's navigate method in your TypeScript code to programmatically navigate based on user input or other events. Creating dynamic views. One of the most powerful features of the router is its ability to create dynamic views based on the current route. By using route parameters and data, you can create components that display different information depending on the current URL. For example, you could create a product detail component that displays information about a specific product based on a URL parameter that identifies the product ID. Handling authentication and authorization. The router can also be used to handle authentication and authorization within your application. By defining guards that protect certain routes, you can ensure that users are only able to access parts of your application that they have permission to view. Overall, the Angular router is a critical component of any Angular application as it provides powerful tools for managing navigation and creating dynamic views. By using the router effectively, you can create a more organized and intuitive user experience that makes it easy for users to navigate your application and find the information they need. What is ngZone in Angular? How to implement ngZone in Angular? ngZone is a service provided by Angular that enables you to execute code inside or outside the Angular zone. The Angular zone is a fundamental concept in Angular's change detection system. It is a wrapper around the execution context, i.e., the scope, of your application. When a change detection cycle runs, Angular runs its code inside the zone to track changes and update the view. ngZone provides a mechanism to run code either inside or outside the Angular zone. This can be useful in scenarios where you need to execute code that may trigger change detection, but you don't want to run the entire change detection cycle. Here is an example of how to use ngZone. In the example above, we inject ngZone into our components constructor and then use its run outside Angular and run methods to run our code either inside or outside the Angular zone. When we run the code outside the zone, any changes made to our component's properties won't trigger change detection, which can improve performance. However, when we run the code inside the zone, any changes made to our component's properties will trigger change detection, which is necessary to update the view. Why async pipe in Angular? In Angular, the async pipe is a built-in pipe that allows you to subscribe to and automatically unwrap an asynchronous data source, such as an observable or promise. Using the async pipe in your template simplifies your code by eliminating the need to manually subscribe to and unsubscribe from the data source. Instead, you can simply pass the observable or promise to the async pipe, and it will subscribe to the data source for you and automatically update the view whenever new data arrives. The async pipe in Angular provides several benefits, including: the first benefit is simplified code. Using the async pipe can simplify your code by eliminating the need for manually subscribing and unsubscribing from the data source. The second benefit is automatic change detection. The async pipe automatically triggers change detection when new data is emitted from the data source, so you don't have to manually trigger it yourself. The third benefit is improved performance. The async pipe improves performance by reducing the number of unnecessary change detection cycles. Since the async pipe only triggers change detection when new data is emitted from the data source, it avoids unnecessary change detection cycles that can degrade performance. The fourth benefit is better error handling. The async pipe handles errors more gracefully than manual subscription. When an error occurs in the data source, the async pipe unsubscribes from the data source and marks the observable as errored, which can be helpful for debugging and error handling. Here is an example of using the async pipe with an observable. In this example, my observable is an observable that emits some data over time. The async pipe subscribes to the observable and returns the latest value emitted by the observable. The *ngif directive ensures that the template is only rendered when my data is truthy. By using the async pipe, you don't have to manually subscribe to the observable in your component code, and Angular takes care of unsubscribing from the observable when the component is destroyed. Overall, the async pipe is a powerful tool in Angular that simplifies your code, improves performance, and makes error handling easier.